Hello folks, welcome to this next video on the encoder support in the T-STorM32 gimbal controller. And the main reason for doing this video is because there had been some discussion about why I'm doing it like this or that, or not doing it like another way, and so on and so forth. And so in this video I want to show you a bit about the concept behind this encoder support in this STorM32 controller, show you a little bit how it is set up and how this firmware works. So the hope is that this will give you a better idea of what this is all about. Now let me start with the basic concept of what I have used. And let me contrast this to the concept which is used by Alex Moss, which is very familiar to all of you, I guess. And for that I'd like to show you the basic diagram which you can find in this encoder manual. And the idea here is that you have the encoders and they are directly connected to the main controller board. And this you can do for all encoders for each motor. So the result is that you end up with a setup which looks like this. That you have your main controller board, you have your three motors, and each motor is connected, the motor wires are connected to the motor drivers on the main controller board, but in addition you have encoders on the motors and they are also wired to the main encoder board. So the advantage of the setup is that it's quite easy to get into it, because you only have to get some encoders added to the motors and connected to the main board and you're all set. Now the concept which I'm following is quite different in that, and it's shown here. Namely, what I'm doing is that I consider the unit consisting of the motor, when the encoder and the motor driver, I consider this as one unit. So from a perspective of the main controller, the gimbal controller, it doesn't actually know what type of motor or encoder and whatever motor driver you're using. From the viewpoint of this main controller board, that's just a speed controlled motor, so to say. Okay, and this distinction between looking at this as one unit and the main controller board, you also can see then in the setup procedure. Now what does this mean? When you look at the scheme here, it implies that of course you have your main controller board here with a microcontroller on it which does all the job, but then that each motor combined with such a motor module which includes an encoder, a motor driver, and again a microcontroller, with all this constitutes, so to say, the motor, which consists of the motor itself and this motor module. And you need this 3 times. So for all these accesses you need this 3 times. Now at first this looks like a disadvantage, because it makes getting built or getting into this concept a bit harder, because you need this dedicated motor modules and you need all these additional microcontrollers and so on and so forth. However, I think that this concept has quite some advantages. It allows us to do some things in the future which would not be possible otherwise, and I think that this will lead to some significant performance improvements, which we are all after. And so that's, I think, worthwhile from this perspective. And it's also not much more expensive, because actually I think that these motor modules can be produced or built at the cost of 10 euros. And if you are 10 to 15 euros, let's say, and if you look at the cost which you have to pay for Alex Moss for just the encoder, it's usually also in the price range of $10 to $20. So that's not, I think cost-wise, it's not a big disadvantage going along this route. Okay, so this was a basic concept to look or to consider this motor and motor module piece as one unit. And in order to show you now how all this is set up and so on, I don't want to do this on this ready built controller or gimbal stick. I want to show you this on my test system. It's essentially the same thing, just one axis. So here you have your motor, attached to the motor a magnet, and then on this underside of this PCB you have your encoder. And here you can see then the motor driver and this additional microcontroller which does the job to control the motor. And then of course you have the wirings going to the motor. And here I use a V2.4 gimbal controller board. It's just rudimentary, so it's just one axis, no IMU and so on. But that's for the moment, that's sufficient for what I want to show you. And the setup of the gimbal now consists of two basic steps. First, you have to set up this unit consisting of this motor and motor module in the first step, and then in the second step you have to adjust some parameters in the gimbal controller. And what I want to show you here is the first step. So I connect this to my computer via this USB cable, and then we of course need some battery. Okay, so and the function principle is now like this, that this main controller board we set up now in a mode in which it just works as a tunnel. So through this USB coming from a PC, we can talk directly to this motor module via this main controller board by going into a particular mode. And for doing that, we need a terminal, a standard terminal. So in a later version of the firmware, probably all this setting up this motor module will go also into the GUI for this main controller board, but at the moment it's not yet at this stage. So in order to set up this motor module, you need to start a terminal, and we connect it to the main controller board. Oops, there's something. Here I have to change this. Here we are. Okay, now we are connected. And in order to open this tunnel, we have to type in a particular keyword. So I will show it in a moment. So XQT NTQ mode. So that's the keyword. And since we want to open the tunnel to the motor pitch module, which has the NT ID 4, we have to enter here 0.4 to open the tunnel. So I press now enter, and you will see that the terminal will respond. So we have opened now the tunnel to this motor pitch module, and it tells us, hello, I'm motor pitch, to tell us that we are now talking to it. Okay, so this was opening the tunnel, and now we can start setting up this motor module, and for that we have a number of comments which we can enter. And the first thing we need to check is that actually the encoder and magnet are arranged properly. That is, that the magnet strength produces a reasonable signal in the encoder, and for that I have a comment which I called range, which is this one, and when I press this enter, you will see that the motor starts to rotate. It's like this, and during this rotation the raw encoder data signals are measured, and here you can see the output. So on the X channel you have a minimum value of -10,000 and a maximum value of about 9,000. So that's exactly in the good range. And the same thing you have on the Y channel, and there had been no error detected and so on. So this means that the encoder and the magnets are set up well and are working in a good range. Now the next thing is to determine the number of the motor poles. And for that there's also a comment which is RPP. So actually what we are measuring is not the number of poles but the number of pole pairs. Okay, so when I press again here, the motor will start again to rotate, and during this procedure, during this rotation, the motor module will measure the number of poles, motor poles, and here we have a 14-pole motor, which means that we have 7 pole pairs. So this has been found now, and the last step what we need to do is to determine the offset between the electrical angle and the mechanical angle, and for that we have also a comment which is called R-offs. And when I enter this, again the motor starts to rotate, and this takes now a bit longer since it has to do a bit more things to get a reliable offset. So it rotates first 4 times in one direction and then rotates back 4 times in the other direction. And I said this takes a short while, so we can look to that now. Okay, so that's not very exciting, I admit that, but it's doing its job. And now it rotates back. Okay, we might be close to finishing. Let's see. Okay, so this might be the last turn. Okay, so we are finished. And here that's the output, what comes out. And the main value is that here it has determined the offset value. And this value is then folded back into, is wrapped into the range of the electrical angle. And so this is then our final result here. Okay, and now so the motor module is set up. So we have to store all this into its EEPROM. So we enter store like this and press enter. And now our module is ready to go. So this was it. Now that's not all what you can do. Actually, the firmware which I've produced so far already allows to take quite some measurements in order to determine the quality and performance of your motor. And that's actually a very useful thing. I had in fact one case where I took this data and then I realized that the motor has a serious problem. So I could investigate this problem and resolve the problem and get a reasonably well working motor. And I think that's actually a very good thing, because many gimbal builds will suffer from the quality from the motors, especially when you build a small gimbal with small motors. They can be good or bad, and of course a bad motor doesn't produce good results. So you can investigate that. And just to give you a glimpse of what's possible, one particular test procedure is to let it run and to measure the speed of the motor, and this can be enacted by entering the comment which I've called R5. And when I start this comment now, you will see what is happening. There will be some open loop speed comments sent to the motor with different speeds. So you can see, so that's the maximum speed. And when it goes into the other direction, okay, and the result of that is that you get again some output statistics, and the key point is, for example, you can measure the maximum speed, which is about 1400 RPMs for this motor. So this divided by 11 volts from the battery gives you then the kV value of your motor. But that's still not all you can do. You also can actually record some data, and this you can do by opening a stream. I open stream 2, and then again this command R5, like this. And in order to measure the data, there's a special version of the NT-Logger tool, which is here. And you start it to record. So I press here this, and now I enter my comment, and the motor will then start again to rotate. But at the same time, you're getting some real data out of this test procedure. And that's then really the big advantage, because you can analyze this data and can make conclusions about your motor and performance and so on and so forth. And I expect that in future the possibilities here will dramatically improve what you can do with that. Okay, so this was to show you the basic procedure of setting up of such a motor module. And there had been actually one additional reason why I did this on this test setup, because in order to do that, there should be no load on the motor. So here's now this small thing attached, which is not, it shouldn't be there actually, but it's not very light, so that it doesn't disturb the motion of the motor too much. However, you can't do this procedure with a gimbal ready build. So what you would have to do in order to set up this motor module, that you have to disassemble your gimbal and then do this for each of these motors, and then you can assemble your gimbal. So that's a slight disadvantage at the moment. You get very high quality information on your motors, and maybe in a later firmware version all this might significantly improve in terms of ease of use. Okay, so this was the procedure to set up your motor modules. And the next step, the second step then, is to set up your gimbal controller. And so we can remove all that, take our gimbal, and for that you again use, of course, the GUI as you're used to use it. And there's now actually one particular thing in this GUI, namely, I need my USB cable here. But when you start using this T-STorM firmware and connect it to the GUI, you actually will not notice any difference. And that's because the whole setup can be put by clicking one option, one flag, into this old STorM32 controller mode, and then into this encoder mode, and without doing anything on your setup or working out anything here. And I think that's also a good thing, because this allows us to directly confirm the performance with encoders and without encoders. Now in this, as it is now like this, it's working like the ordinary STorM. So I can show you this. So when I start this up, like this here, you can see this typical startup procedure for the old STorM and the time it takes. And finally it's working, and you can notice that it's the old firmware by putting a disturbance on, for example, your axis. Now the STorM can reject it, so it can recover from that. However, it feels a bit like this. Okay, so that's the old traditional mode, and now we can put it into the encoder mode by simply connecting to the GUI. So we are connected now. So we connect now to the GUI, and then there's one particular option which you can find here: change encoder support. So we switch it now and we set it to on, and now the whole things get reconfigured. So the firmware gets reconfigured and the GUI also gets reconfigured, and you notice, for example, that there's now a status field encoders are present, which they are, and here the encoders are okay, and so on and so forth. So now we have set up the gimbal to work with the encoders. So we can restart our gimbal. So we we start it up. And now the startup procedure, you will see it's much more reliable. It goes quite fast. Or not. Maybe I restart it. I'm shaking too much. So now it has stabilized. And now we are in encoder mode, and you can notice it, for example, by how the rejection here works, how strong and stiff with disturbances are rejected. So that's the encoder mode. And in order to set up this encoder mode, I want also to show you this as the last thing. This consists now of two pieces to do. So when we switch this off, we again have to connect, of course, to set the gimbal off. And the first thing we need to do is that we adjust the zero positions. So we need to find the encoder zero positions. Oh, there's something stiff here. Sorry. Okay. And for that you just hold the gimbal into a square upright position. And then what you would do is you would go to the tools menu, and you would press this option here, get current encoder positions. And what this would do is that in this gimbal configuration it would set the zero positions values to the correct values. So that's the first parameters to determine, so it's not quite difficult. It's a bit mechanical work, but straightforward. And then the second thing to do is that you need to adjust the motor directions, and that's also quite simple. So for the sake of showing it, I do it this, put the wrong direction for the pitch axis, and in order to see if this is correct or not, you take your gimbal, you start the data display, and we just look now at the angles coming from the pitch axis. So that's the pitch IMU angle, and that's here the encoder angle. So you get two values. And on this display, you take your pitch, put it into a roughly correct position. And if it's roughly correct, the zero positions are set roughly correct when these angles agree. But now you move the pitch axis around, and what you will see when you're doing so, that the angle for the pitch axis and the angle for the encoder axis will go in opposite directions. So this directly tells you that the direction of your motor, of your pitch is incorrect. So what you have to do is you go to the GUI, you set this value to the correct value, like this, and then you can double check this in the data display, so it's not running. And if we do now the same thing again, so we're moving it up and down the pitch axis, and now you can see that the two angles go in the same direction when you move them around. And this tells you that you have the right direction. Of this pitch axis. And this you repeat for all three axes, and then your gimbal is set ready to go. And the last step would be then, of course, to go to the pit parameters. And that's actually a good thing about the encoders, because setting up the pit parameters is much easier. It's quite straightforward actually to set this up, but that's probably an information or piece of discussion for another video. Okay, so this is what I wanted to show you. I hope that you got some deeper insight into how all this thing with this T-STorM32 gimbal controller is working. Have a nice day. Cheers.